Okay, so good morning, or whichever time it is that you'll be looking at this. I hope you are well. This is Bio 321, Advanced Ecology. I'm sure you already have been taken through the fundamentals of ecology, so you know the basics in it. So with Advanced Ecology, we will set off from looking first at population ecology. And population ecology is a combination of two words. One is population and the other is the ecology. When you think of ecology, is how living organisms in a particular area are interacting, both with the living and the non-living factors within that environment. So with the population ecology, therefore, you are combining how the population that you are looking at, how the features, the characteristics of that population, how those population, the characteristics of that population are changing. So for example, the size, how many organisms, how many trees, how many people, how many animals, and within that number, what is the structure? How many female, how many male? Okay, how many tall, how many short? So how can we divide that population? On which characteristics? Then another thing you look at is that population increasing or decreasing? So what is the growth like? Does it have a positive growth? Does it have a negative growth? Okay. And how now that population, the group of organisms that you are interested in, is interacting with the environment. Okay. The environment is the immediate surrounding. With the immediate surrounding, there will be living things and there will be non-living things, the biotic and the abiotic factors. So with the population ecology, it is a branch of ecology which is focusing on the study of populations. And when you study these populations, you look at their size. So how many are they in a given environment? What is their structure? How can you divide them up? If you say you are looking at how many males, how many females, how many old, how many young, how many tall, how many short. Okay, so that is structuring. Then another thing you are interested in is to know, is this group of organisms, is it increasing? If for example you are keeping animals, labda unafuga kuku, your interest is hizi kuku zinaendelea kuwa mingi ama zinaendelea kuwa kidogo. So you want to see how they are growing. Then how are they interacting with each other? The chicken will be living together, several of them. So zinapigana, and within that environment where they are living, there is temperature, which is an abiotic factor. Okay. Then there could be disease. There are disease-causing microorganisms within that environment. So how are these organisms that you are interested in, how are they interacting with that environment? In this case, the environment is made up of two main factors, biotic factors and abiotic factors. The biotic factors are other living organisms within that environment. Then the abiotic ones, now you are talking of temperature. You are talking of the general climate. Okay, so things that are affecting the organisms, but they themselves are not living. So they are non-living factors. Those are the abiotic factors. So trying to understand population ecology is essential for any given population that you are interested in. You can think of when you have a wildlife reserve, a game reserve. At some point, the Kenya Wildlife Service will be interested to know, do we have the population of elephants increasing or the population of elephants is decreasing? Then, how many males, how many females? Okay, so that is population ecology. In terms of agriculture, if you are keeping livestock, umefuga ng'ombe, utataka kujua hizi ng'ombe zinazaana zinakuwa mingi ama zinapunguka? Na zikikuwa hivi, how many of them ni of which age? Kuna zenye nakamua, kuna zenye bado ziko. So the structure. Okay. Then in terms of resource management, in any environment there are resources. It could be water, it could be grass, anything that is within the environment which the population that is relying on that environment is deriving benefit from. So ni maji, minerals, okay? So you want to know the animals, the population you keep, ni mingi kuliko ile maji iko hapo, ni mingi kuliko ile nyasi iko hapo, ama iko namna gani? So you have to understand your population with respect to the environment. So in population ecology, there are several concepts, okay, that you really have to understand so that you, when you talk about population ecology, then it makes more sense. So one of it is the term population. When you talk of population in this sense, you are referring to that group of individuals or organisms of the same species who are living in a specific geographical area. So it's a group of organisms. If you are talking of trees, then it has to be either eucalyptus, cypress. That's now the population. Okay, you can have a forest which has eucalyptus, cypress, and the indigenous. But when you talk of a population, then you now narrow down to either just eucalyptus, just cypress, just a particular species, a single species. Okay, so if, for example, you keep cattle, you keep sheep, you keep donkeys, you keep camels, when you talk of a population, that is not the total, is not your population. Your population is either you are referring to cattle, you are referring to sheep, you are referring to goats, you are referring to donkeys. So a population is a group of organisms belonging to the same species and living in a specific geographical area. So the example we have here is, for example, when you are talking of elephants that are found in the Amboseli National Park. So when you go to Amboseli, you don't just find elephants alone. There will be elephants, lions, zebras, leopards. But when we talk of a population, then we just narrow down to a particular species. So you'll have, for example, elephants in Amboseli. You have elephants in Mount Elgon here. But when you are talking of a population, then you are referring to a specific geographical region. So you don't refer to the population in Mount Elgon and think of it as a population again with the Amboseli. So these are different because even though they are of the same species, but they don't live in a same geographical area. Okay. So the second important concept is population density. So population is the group of organisms of the same species living in a particular area. But now that area will be having some maybe measurements. So you can come up with an area of a particular national park, for example, will be this meters squared. So population density refers to the number of individuals per unit area. Per unit area, which means you can have 10 animals in a 10 by 10 meters by 10 meters. So when you do your 10 meters by 10 meters and you get the area of that particular region, then you take the number of animals that are living in that particular area, then it gives you the density. If you are talking of aquatic organisms, then you think of volume. So if you are talking of fish, hii samaki inapatikana kwa maji kiasi gani? If you are talking of bacteria yenye inapatikana ndani ya maji, then you talk of volume. So density is about the number of individuals per unit area or per unit volume. So there will be a high density when you have a high number of individuals in a particular area. Okay, then the density will decrease when the number of individuals decrease as well. So you can think of, if we talk of herbivores, the population density of herbivores in a particular area is likely to increase when there is rain, because mvua ikinyesha nyasi inakuwa mingi, then the animals that rely on the grass will now come in na zikuwe mingi. That will increase the population density. But during drought, the expectation is the animals will move out. If not, some will even do what? Die. So population density is about the number of individuals, the number of organisms per unit area. Okay, per unit area. So there are several factors that will affect the number of organisms that can be found in a particular area. So there are several. One is the non-living, so the abiotic factors. So with the abiotic factors, you are talking of things like climate. With climate, we can now refer to temperature and rainfall, which will always influence population sizes. So during dry seasons, for example, there is reduced water availability. Once water is not available, or it's available in a lower amount, then the herbivore populations will decrease. Okay. Within still the abiotic factors, we have the natural disasters. When you have floods, when you have fire, when you have drought, the expectation is the animals or the organisms that were present in an area where disaster struck, most of them will either live or die. Living hiyo ya kutoka kuenda yani. Okay. So tukikuwa na moto itachoma iue miti. Okay. Tukikuwa na moto, animals that can run away will run away. Okay. When there are floods, so many animals will be killed, so many plants will be washed away. So this will then lead to a reduction of the number, a reduction of the size within the area that the disaster struck. The second group of factors is the biotic, now the living. So the biotic factors. One of it is food availability. When you talk of grass, grass is a living thing, plants are living. So when you have a decrease in the availability of plants, then the population of herbivores will decrease, okay, because the food is scarce. Still within the biotic factors, you have a relationship that we call predation. So when you have predators, you increase predators, the animals which are fed on, which are predated upon, will decrease. Okay, so in this example, if we have an increase in lions, we can potentially lead to a decrease in the number of gazelles. Okay, then now the third factor within the biotic factor is the disease. Diseases, most of them are brought about by microorganisms. So when you have a disease, it is caused by a living factor. So such a disease can easily lead to a reduction in the number of particular organisms in an area. Okay, so biotic factors, living factors, you talk of food, you talk of predation, you talk of disease. The third factor are the human activities. So as human beings, we derive our livelihood as well from the ecosystem. So we rely on the environment. At times, for example, we will need to increase land where we can farm or where we can build our houses. So that is deforestation. As you are cutting down a forest, you are destroying a habitat for some other animal. So what happens is, as you reduce the habitat, unapunguza pahali penye hao wanyama wanaishi, itamaanisha hao wanyama watahama waende pahali pengine. That will have led to a reduction. Okay, because you've reduced the habitat, you've reduced the houses for those animals. So they have to move to a different area. As they move out of an area, they will have changed the population density because they are moving from one place to another. The population density will reduce from where they are coming from and increase where they are going to. The other human activity that will lead to a reduction or a change in population density is poaching. Poaching is killing animals. Okay? Poaching is killing animals. So poaching will lead to a decrease. If you are poaching elephants for their tusks, if you are poaching rhinos for their horns, okay, or you are hunting down gazelles, at the end of the day, poaching will lead to a decrease in the numbers. As the numbers reduce, the population density also does what? Reduces. Another bit is urbanization. So with urbanization, we are forced now to convert actively areas into human settlement, or we build factories. Okay, so what that means, unapunguza habitat ya wildlife. You are cutting down a forest to build a market. I think recently when was it the president or the deputy president, they came to Trans Nzoia, then towards the border of Trans Nzoia and Uganda, they talked of clearing around 50 acres of the forest so that they can create a border market. So you can think of that. When they will clear 50 acres, that will mean wamepunguza habitat ya wildlife by 50 acres. So what will that imply? The animals that were living in the 50 acres will have to move. So that will lead to a change in the population density in that particular area. So that is urbanization. We create an urban setup as we now reduce the wildlife habitats. Okay. So when you look at how organisms exist in the environment, they are distributed or they are dispersed across the environment. So population distribution refers to either how people or organisms are spread out in a particular area. Okay, so it shows the pattern through which organisms are settled across a particular area. The main patterns through which populations can be dispersed or populations can be distributed in a particular area are either clumped, ile wanaonekana kwa vikundi. Okay? So with a clumped dispersion or clumped distribution, the organisms are grouped together in just certain areas. Okay, so you move from a particular area, there are no people or there are no bacteria, but when you get to a certain place, then you find there is a group. Then ukitoka hapo, in between there is nothing. Okay, so a clumped dispersion or a clumped distribution is when organisms are grouped together just in certain areas. So this happens where there are more resources. So for example, you'll find more people closer to a water source, to cities, because that's where they can easily derive their livelihood, or to a place where there is a good farmland. So then most organisms tend to live in places where they can get the most benefits. Okay? So you can think of hata hapa kama ni, if you go to areas where kuna vita all the time, so insecurity is so high, you'll find people living together in groups, because the more they are, the higher the chance that they can defeat whoever is coming to attack them. Okay, so with the clumped, it means you find people grouped together just in certain areas, and what determines that is the nature of resources that people want. Is it water? Is it city life? Is it security? Is it a school? So you'll find people tend to move closer to a place where they can derive the most benefits. Okay, so that is a clumped distribution or a clumped dispersion. The next one is a uniform dispersion or uniform distribution. In this, organisms are spread out almost evenly across the region that they are occupying. So they have almost a similar distance in between. Okay, so this will happen in areas where there is competition for resources. So it means you have to move away from your competitor as much as possible. Okay, with the clubbed, all of you are attracted to a common source, but with uniform dispersion, you sort of move away from your competitor because you want to derive the best from what you have. So you find, for example, in farming areas, people are spread out so that wewe ukwenda shamba yako hapa, ulime kutoka hapa paka hapa, mtu mwingine aishi hapo akilima kutoka hapa akienda mbele. Okay, so where there is a fairly high level of competition, then you'll find almost some uniform distribution of organisms across that environment. The last one is the random distribution or random dispersion. In this, you find organisms being spread out in a more irregular way. So there is totally no clear pattern. You cannot say they are clumped together or the distance from one to the other is uniform. It is extremely random. Unapata pali pengine huyu kutoka kwa huyu paka kwa mwingine ni 10 meters. Kutoka kwa 10 meters kwenda kwa mwingine is like 50. Okay? So there is no pattern totally. Okay? So for human populations, random dispersion can be rare. Okay? It can be fairly rare. But it might happen in areas where there is a lot of land and very few resources. So there is nothing that will attract you to go and live together. Okay? So land is large, especially in areas like Turkana or Masai, where individuals don't own land. Land is communal. So you can live anywhere within that particular land. So in such a case then, you'll find people living randomly. Sababu hii shamba si ya mtu. So naweza ishi hapa, mwingine aishi huko, mwingine aishi huko. Na hakuna ati maji iko mahali fulani sasa sisi wote tusonge hapo kwa maji tukue clumped. Hapana. So with the random dispersion, you find organisms distributed in a random way. Okay? So you don't have a clear pattern. And this will happen mostly where there is a lot of land but very few resources. Okay, so nothing attracts you, and equally there is nothing like insecurity. So you don't need to move close to each other. There is no insecurity. There are no other resources that you want all of you to be attracted to. So you can be found dispersed anywhere. So in summary, the dispersion or distribution of a population is how the organisms that make up that population are arranged in an area. This dispersion happens in three ways. They can be grouped together, the clumped distribution. They can be spread evenly across the uniform distribution, or they can be scattered randomly across that area. That is what we are calling the random dispersion. Okay. So, as you can see, I think it's on page 4 of your notes. You have a diagram showing the first one is the clumped. Okay. So you go kwa vikundi vikundi. Then the random one, it is just all over with no clear pattern. But with the uniform one, there is sort of a pattern. Okay. There is sort of a pattern in the spread across that particular area. Okay. So let's now think of population growth. It is in the interest of all of us to know whether the organisms that are making up a certain population are either increasing or decreasing. We can think of being interested to know, to hope that they're increasing if the organisms are giving us benefit. We are deriving benefit from them. Kama umepanda miti ama unafuga wanyama, you will wish that the numbers increase. But when you are talking of someone who is sick, kwa ndani ya mwili yake atakuwa na plasmodium ama atakuwa na particular virus, the hope of whoever is treating that person is that the population of the disease-causing microorganism decreases. So that is about population growth. So population growth refers to the changes that are occurring in the population size. Okay, so the size is about numbers. Is the number increasing or decreasing over time? So you can say, my population has increased by this within 1 year. That is the time. Within 4 days, if we are talking of organisms that have a very short reproductive cycle. So there is an aspect of time when you are talking of population growth. Okay, so it's about the change in the number of the organisms that make up that population within a particular period of time. So the growth, the changes in the size of that population will be influenced either by the number of births, the birth rates, or how people are dying within that population, or if people are moving out or moving in. Okay, so then it means the population growth of any group of organisms is influenced by birth rates, death rates, immigration, which means to immigrate is to come, to enter a population, and lastly, emigration, which is now moving out. Okay, so birth rates and immigration will lead to an increase because it is adding into the number. But death rates and emigration will lead to a decrease. Sababu hiyo inapunguza. Okay? So the size of populations mostly will grow through two major ways. One of it is it can grow in an exponential model, or the other one is that it can grow or increase in a logistic model. So when you look at these two, the key components to note, the key points to note here is in exponential growth, the growth rate, the increase in the population stays the same regardless of the population size. So if you are thinking of a population is increasing by 2, if you have 1, it doubles. If you have 2, it doubles. It will increase like that forever. That is in an exponential growth. Okay? But when you think of any population in nature, because remember, the individuals that make up a particular population are relying on an environment. They rely there for food, okay? They get water from there, and equally, they are giving out their wastes. So then it means when you have organisms in a particular environment, sorry, they cannot have a growth rate that doesn't change forever, okay? Because they will be limited at some point, either by the resource availability, kama ni zile zinakula nyasi, nyasi itafika mahali ipunguke, okay? Wakati ya kiangazi nyasi itapunguka. So at that particular point, then you expect that then the increase will have to sort of stop. So besides even the resource availability, if you keep organisms in a given place, as much as you are feeding them, they are also giving out waste. So as the waste accumulation increases in the environment, because the numbers are increasing, which means if you had 2 today, you have 4, then you have 8, then you have 16, like that. So when you had 2, and at some point now you have 32 within the same area, surely the accumulation of waste will now be higher. So what that means is that the available resources and the presence of increased waste in the environment will now begin to limit growth. And that is now what describes the logistic growth model. So in the logistic growth model, a population's growth rate gets smaller and smaller as the size of a population approaches a maximum which that particular environment can support. So a particular environment can support just a given number of organisms. For example, ukiwa na shamba eka 2, surely you cannot keep 50 animals hapo zenye zinatembea zikikula kila mahali, but you can keep maybe 2 or 3. So if you keep increasing the number of animals on that size of your shamba, 1, there will be not enough material for the animals to graze. So it gets to a level where now the resources that are available in that particular environment limits the capacity, the carrying capacity. Carrying capacity kwa gari inaweza beba watu wangapi? Kama gari ni ya watu 4 ama 5, wakishakaa kwa hiyo viti, if you bring in any other person, then you realize there is no space for that, for the extra person you are bringing in. The same thing happens for an ecosystem. It has a carrying capacity. So in the exponential growth, the assumption is there is no carrying capacity. But in reality, every ecosystem has a carrying capacity, which is the highest number of organisms that that particular ecosystem can support sustainably. So in logistic growth, as the number tends to approach the carrying capacity, then the rate of increase drops. Then the rate of increase drops. But in the exponential growth, the assumption is there is no limitation. So it will grow forever. Okay? It will grow forever. So the exponential growth then will result in a J-shaped curve, while the logistic growth will produce an S-shaped curve. Okay. So when you read through, you just realize that the description is showing that in nature we don't have exponential growth curves, but we have the logistic growth models. Okay. Why? Because every ecosystem comes with a carrying capacity. So as the numbers of that particular organism in the population that you are monitoring the growth, as those numbers approach the carrying capacity of that ecosystem, then the growth curve will begin to flatten. So it forms now the S shape. But with the J shape, inaenda ikienda kabisa. But the reality is they don't grow forever. Okay, they don't grow forever. So I will not take you too much through the mathematics, but you can read through, and it is largely self-explanatory. Okay, but when you look at on page 7, when you look at page 7, where now you have the dn over dt. So the dn, n is the numbers. So the change in the number of organisms per period of time, the change in time. So you have, maybe you began with the 10. Okay, you began with the 10 in 2020. Now we are in 2025 and they are 15. So the change is 15 minus 10. Then the change in time is 2025 minus 2020. That is the change in time. So the change, the rate of growth, how the population has changed, you look at the numbers, but you must also have some time frame in mind. When it was 10, when was that? When the population now is 25, then now you have an idea that it has changed from 10 to 25 within 4 years. So you can have a rate of growth. Okay, you can have a rate of growth. So with this rate, if you look at their arrows on page 7, which are coming from the rate, one is the exponential growth. With it, the growth rate does not change, even if the population gets very large. Okay, so even as the population increases in size, as you look at the curve, the population size n, as it keeps increasing, that rate of increase does not change. Okay, but we've seen that we have the carrying capacity, which now makes the exponential growth not to be a reality, not to be practical in nature. But when you look at the logistic growth, the growth rate gets smaller and smaller as the population approaches its maximum size. That maximum size is what we are calling the carrying capacity. So as the number increases towards the carrying capacity, gari ikija, there is supposed not to be any other increase in the population within that vehicle, because mtu mwingine akikuja atakaa wapi? So the reality is, kama gari haina watu, akiingia mmoja, wakiingia wawili, the population within the vehicle continues to increase. But as it gets towards the maximum, then there cannot be any further increase. That is the logistic growth. So in nature, therefore, okay, when you look at those two graphs, one, you have population size versus time in both. In the exponential growth, the assumption is there is no limit. Okay, but in reality, in nature, we have a limit. So which means an ecosystem can only accommodate just as much as it can support. Okay, the ecosystem can only accommodate just as much as it can support. And therefore logistic growth curve or growth model inasema the population growth rate will get smaller or will reduce or will slow down as the population approaches the carrying capacity of that particular ecosystem. And now that is the reality. Okay, that is the reality. So when you look at the exponential growth, you're just talking of an infinite growth. There is no stop. Okay, so with that, you now end up with a curve like what you find on page 8, because the growth is increasing forever. The growth is increasing forever, but that's not the reality. But when you look at now the logistic growth, is that the growth rate will begin when there are few individuals. They will increase because there is not enough competition. But as the resources begin to get used up, then the growth rate begins to slow down. And eventually, that growth rate will plateau or will level off. When does it level off? When the numbers of the organisms are now equivalent to the carrying capacity of that particular ecosystem. Then, now that is what leads to the curve that you see on page 10, the logistic growth curve. The population increases kama watu ni wachache wanaongezeka. As it begins, there is an exponential growth phase. But then as it increases towards the carrying capacity, which is now that red dotted line, at that particular point, one, the available resources will have been almost used up. Then two, because the population size is increasing, but the available resources imebaki tu hivyo hivyo. As the population size increases, they not only just use up the resources, but they also lead to a continuous accumulation of waste. Then it means now that ecosystem is not able to sustain a growth rate that is as high as it was when the population was smaller. So that's what now makes the growth rate to begin to level off. Ndio inatengeneza the S shape that we are talking about. So time is increasing, but it gets to a point, even if you increase time, you cannot increase the number. Hiyo inasaidia when you are determining, for example, how many animals can you keep. Unaweza weka kuku wangapi kwa nyumba. If you have a particular size, unaweza weka kuku wangapi. Unaweza fuga ng'ombe wangapi. Everybody will desire to have as many as possible, but we are limited based on the carrying capacity of that particular ecosystem. So I will spare you the mathematics, but you can read through. I know some of you take biology mathematics, so you should enjoy the mathematics. But again, I know quite a number of you, mathematics is your mother or your father-in-law, depending on your gender. Okay, but you can read through and hopefully you will enjoy the maths. So we've been talking about the carrying capacity, which is represented by a capital K. So the carrying capacity just refers to the number, the maximum number of organisms or individuals that any given environment can support sustainably. The word is sustainably, not just the maximum number of individuals that an environment can support. No, it has to support sustainably. So if you are defining carrying capacity, remember it's the maximum number of organisms that a given environment or ecosystem can support in a sustainable manner. Sustainably meaning the environment can now keep providing for the organisms that are relying on it without an external support. Okay. Ukiwa na so many animals, even if the place where you are taking care of them ni padogo, if you are doing zero grazing, for example, you have to go out and look for hay ama uende ununue chakula kwa duka. Now that is looking for external assistance to support the individuals. Okay, but if you have just 1 acre, for example, and you are keeping 1 or 2 animals, surely they should be able, if you manage that piece of land properly, the 1 or 2 animals should just eat from that piece of land without really desiring any external support. Okay, so when you think of carrying capacity, it's the maximum number that of organisms or individuals that a particular ecosystem can support sustainably. Okay, but now which factors can determine the carrying capacity of a given ecosystem? So the factors which determine the carrying capacity of any ecosystem are the factors that will be supporting that particular organism. So if you talk of plants, then the factors that will determine the carrying capacity of the plants within a particular ecosystem, you are talking of water. How much water is available? Sunlight, because photosynthesis. The nutrients, okay, is the area fertile ama itabidi utafute manure ama utafute mbolea ingine ukuje uweke. Then generally the space, okay, if you have 10 meters by 10 meters, how many plants can you grow there? Ni kama uko na 1 plot unataka kupanda mahindi itoshane na mtu mwenye ako na nusu eka. Okay, so what will determine unapanda mahindi kiasi gani kwa hiyo shamba uko nayo ni if you want to have a proper harvest, then you decide utapanda with the recommended spacing na upate whatever you deserve. For animals, what will determine the carrying capacity is the availability of food. Because remember, animals, we don't make our own food. Okay, so we need either producers to be there so that we can feed on them. Okay, they will need water, kama ni kuku. They will need shelter. Okay, they will need somewhere to reproduce from. Okay, so kama ni kuku, they will need somewhere to nest. So anytime there is a limitation in these factors, for plants, if there is little water, there is sunlight in a haipatikani vizuri, nutrients and the space. For animals, if there is not enough food, there is not enough water, not enough shelter, pahali pa kutaga mayai ama the areas from where they are supposed to reproduce from pia hazipatikani, then that will lead to competition. So the organisms present in that particular environment will now have to begin competing for the limited resources, because you've put so many of them, so many of these organisms in that particular ecosystem, but the ecosystem does not have enough of what they need. Sasa zitaanza compete. If you are thinking of sunlight, for example, if you plant trees na spacing yako ikuwe kidogo, hiyo miti huwa inarefuka kabisa. Okay, inarefuka inaenda juu because it is competing ikuwe mrefu so that ipate nini? Sunlight. But if you planted trees with an increased spacing, then they will not compete to grow tall. Okay? So anytime there is a reduction, anytime there is a limitation in the resources that organisms need from their ecosystem, that limitation will spark off competition. Okay? That limitation will spark off competition. So because we said a population is of the same species, then that type of competition is what we call intra-specific, because it is competition between members of the same population, and a population has members of the same species. Okay. So if there is enough of resources within a particular ecosystem, then it means the organisms present on that ecosystem will not have reached the carrying capacity. So in that case, then there will be no competition. In that case, there will be no competition. In that case, there will be no competition. So therefore, when you want to reduce competition in a particular ecosystem, play about with the numbers. Have organisms lower than the carrying capacity. When you have organisms lower than the carrying capacity, those organisms will not be forced to begin competing for the limited resources. Okay. So you have an example of a logistic growth. That is from page 11. So when you look at the figure on page 12, the graph, so is the amount of yeast and how it is increasing with time. So by the time you get to close to 30 hours, it begins to level off. Okay, so the rate of increase begins to get smaller and smaller. But as you will realize, as you get closer to the carrying capacity, it's possible that the numbers will begin to increase and drop again. Okay, so it will be hitting the capacity, dropping a bit and hitting again, and dropping a bit and hitting again. Okay. So the logistic curve is not that once it gets to the carrying capacity, then it remains smooth. Okay, it can hit up and down, because there are people who will die, then the population decreases. So once the population decreases slightly, then there are more resources. Okay, then now the growth rate increases again. Then it hits the carrying capacity, then it stops. Then a few more die because of old age or other things. Then the rate increases again. Okay, so it's up and down, but in average, it cannot go beyond the carrying capacity. It cannot go beyond the carrying capacity. So, just to summarize, exponential growth will take place when the growth rate stays the same, regardless of the population size. So in exponential growth, the rate of increase is the same, irregardless of the size. So in an exponential growth, there is no carrying capacity. So it means the population growth will be faster and faster. And that will now make it to produce the J shape. But in the logistic growth, the opposite happens. The growth rate will decrease upon nearing the carrying capacity, because there is a limitation of resources. There is an increase in the accumulation of waste. So as the growth rate nears, as the numbers get near to the carrying capacity, the growth rate decreases. So you have an S shape in the logistic growth. But in the exponential growth, the growth rate increases forever. So it is the J shape. Okay, it's the J shape. But now, the factors which affect population growth. We've looked at the models, the exponential growth model, the logistic growth model. So the change in size for any population is affected by several factors. We had mentioned them, okay? But here we just give now closer look. So birth rate, the number of births in a particular population over a period of time, okay? Over a period of time. So when you have a high birth rate, which means watu wanazaana kwa wingi, then we expect that the population will grow faster. Okay, the population will grow faster. So some of the things that can influence the birth rate, one is culture. There are some cultures yenye unazaa watoto wengi, zingine unazaa watoto kidogo. Okay, then the other things which is just the preference, family size preference. So you just decide kwamba sisi tutazaa watoto wawili ama mmoja ama wangapi, you've decided. Then the other one is the access to healthcare. So that will not only affect the ability to get pregnant, but also to sustain the pregnancy and sustain the child even after birth. Because if there is good healthcare services, then upon being pregnant, the woman or the female, in that if it's just an organism, can be taken good care of so that the pregnancy is sustained. Then the delivery has to be done properly. Okay? Then after the young one is brought forth, that young one has to be taken care of to mature. Because if the young one doesn't mature, then we are not guaranteed of another generation again. Okay? Then the second factor is now the death rate. Death rate is the opposite of birth rate. So the number of deaths, the number of people dying, the number of organisms dying within a given population over time. So when the death rate is low, then there will be a higher population growth. But when the death rate is high, then the population growth will be low. Okay. The other factor which we saw was immigration. Immigration is the movement of people into a region. So when more people are moving into a region, that particular population will increase. Okay, so there are several factors that will make, the rural-urban migration. People move from the rural areas to urban areas in search of job opportunity. Currently, we have the crisis in DRC. People are moving from DRC to a different place. Okay, so political stability, job opportunities, general safety will make people to move. Then the other factor is emigration. So immigration is moving into, but emigration is moving out. Okay, so when people move out of a particular region, that is an emigration, and it leads to a reduction in the population. Okay, it leads to a reduction in the population. Another factor that can affect population growth is healthcare. Okay. So if there are improvements in healthcare, then we'll surely have a reduction in death rates. Okay. So there could be diseases in the population, yes, but because the healthcare is being provided, then people will not die. Then now we will have led to a reduction in the death rates. Then we'll have a longer lifespan. So the population growth will be faster. We'll have a higher access to vaccines if we have a challenge of any disease. So healthcare can lead, if you have a very high improvement in healthcare, then it will result to a lower death rate. A lower death rate means a higher population growth. Another thing is education, especially for women. If you educate women, you lead to a smaller family. So the best way to plan families is just to take the girl child to school. Okay? The best way ya kufanya family planning ni kupeleka msichana shuleni. Because if you think of it, now you guys are in third year. When you are in standard 8, ule msichana hakuenda form 1, saa hii alioleka ako na watoto ngapi? Okay? Ule msichana mlifanya na yeye form 4, she didn't join university or college, akaoleka, ako na watoto wangapi? So just because you've been in school throughout, that has delayed your beginning to do what? To give birth. So anytime you educate a woman, you delay kuzaa. Na pia, most of you, God willing, mkimaliza hii masomo, Mungu atawasaidia mpate kazi. And that's my prayer for you. So ukipata kazi na uzae this year, uende maternity leave, because of the professional demand, one, you are educated, so at least you know there is family planning. Okay? So you will have that access to family planning. But two, you cannot be going on maternity leave every year. Employer atashangaa huyu naye ni mgani. Okay? So just because you are educated, it means by being in school, you delayed when to begin having children. But two, by being educated, you are more aware of the family planning methods. But three, because of your profession, you have a professional life, you have a career to keep. Yes, you will want to have children, but not every year. Because now, there could be policies at the place of work. Kwamba unaweza kupata tu watoto ama maternity leave ya hii in this format. So you cannot have it every year. As opposed to a woman who is not a professional. She can give birth every year if that pleases her. Okay? Then the next thing is now the economic factors. So when you look at population growth in various countries is a factor of the economy. So in the wealthier economy, you realize that people are having fewer children because they are focusing more on their careers and financial stability. But in countries that are relatively poorer, there is a higher birth rate, which is linked to the need to have more children so that they can support the family. Okay. So in a wealthier nation, is not the children that will support you. The economy is already stable enough. The social support is already present. But in a poorer country, you think of nikikuwa na mtoto mmoja na nikizeeka atanisaidia namna gani? Wacha nikuwe na watatu, wanne, watano, so that all of them can now help each other in supporting me, supporting the family. Okay? So that is how the economic factors are now leading to the decision on whether people can have many children or fewer children. Okay? Then the social and cultural norms. There are different cultures which prescribe certain number of children. Okay? So different cultures will come up with different expectations. And because we grow up in societies, we will inherit this thinking and this understanding. Then the last bit is the government policy. In Kenya is not so much, but in other areas, in other countries, for example, China, okay, they had imposed kwamba ukuwe tu na mtoto mmoja. So that is already a government policy that is limiting the number of births. And we saw the birth rate is a factor that leads to or affects the growth rate. Okay? So there are ways in which governments can come up with policies, can enforce some regulations which will end up now limiting the number of children that a particular family can have. So when you look at these factors that we've seen impacting on population growth, they are happening or they are occurring in two categories. Some of them rely on the density. So it is a density dependent factor. Okay. Then there are some factors which don't depend on density. We said density is the number of people, number of organisms per given area or per unit volume. Okay. So there will be a size of a particular population which is influenced by a factor that depends on the number of organisms present in that area. That is density dependent. But also, there are some factors which will not rely on the density, but it will still affect the growth. Okay? So both of them, both density dependent and density independent factors, will influence population size, but they work differently. So let's delve in a bit more and see. So with the density dependent factors, these factors have an impact, have an influence on population size. Okay? And they depend on the population density. So in other words, for these factors, their effect will become stronger as the population increases. So for density dependent factors, the effect of a density dependent factor increases as the population density increases. When does the population density increase? When the population size increases. So examples of density dependent factors, for example, is competition for resources. So as you increase the number of organisms in a particular ecosystem, then the competition also increases because the resources will just be the same within that particular environment. So competition is dependent on density because as you move, you increase the population towards the carrying capacity. Okay, Peter carrying capacity, then the competition comes in. So that is dependent on the density, dependent on the population. And its effect increases as the population increases. You begin competing for seats in a lecture hall when you are more than the seats. Kama viti zinatosha, you want to compete. Utangojea tu mtu akae na wewe upite ukae kwa hiyo ingine. Okay? Then the other factor is predation. The presence of predators. Okay? So if there are more individuals in a population, then they can easily attract more predators. Because if they're just one or two, okay, if you are just having one or two, surely it will be pointless to have 4 or 5 predators. Okay. Back in the villages, in our homes, ungeona kama mko na mbuzi ama kondoo, that's where now you have animals coming at night to try and eat them. But when you don't have those animals, you don't have the predators coming. Okay. So when you have more animals that can be predated upon, that is when now you have an increase in the predators. Okay. So predation will be changing the growth rate, but it is dependent on the number of animals that can be predated upon. So it is a density dependent factor. Disease and illness. If the population is crowded, one, it means there are more hosts for the disease-causing microorganism. And because of the crowding, these hosts, if they are susceptible, zinaweza zikaambukizana haraka. So the disease will spread more easily because of that close contact. So there will be a growth in the presence of disease-causing microorganisms. Why? Because of a high density of the susceptible host. Density-dependent factor. Food supply. As the population grows, there may not be enough food for everyone. So leading to what? Malnutrition or starvation. So the key point here is that the density-dependent factors will regulate population size by increasing their effects as the population density rises. So the more individuals in an area, the more likely, for example, there is to be competition for what? For resources. So the density-dependent factors will impact on the population more by increasing their effect as the population density increases. Population density increases when the population size is increasing. Okay? Let's now look at the density independent factors. So with the density independent factors, these are factors that affect the population size irrespective of the population density. Okay? So it doesn't matter whether the population is large or small, they will still influence the size anyway. So for them, it's not about how big or how small, but they will just influence the size. They just influence the population size, the growth. The examples are natural disasters. When you'll have a fire, you'll have an earthquake, a flood, irrespective of the number of individuals that are present. Okay? You'll have extreme weather. There can be drought, irrespective of how big the population size is. So we have pollution, and habitat destruction, which are factors created by anthropogenic influence or human activities. Pollution or habitat destruction will impact the population regardless of how many individuals are present in the area. When you are polluting an area by dumping their waste, it doesn't matter if you are dumping in a town or dumping in a remote area. The number is not important. But the factor of pollution, the factor of habitat destruction will eventually lead to an impact in the population growth, irrespective of the density. So the key point for the density independent factors is that these factors will impact the population randomly, regardless of how large or small that particular population is. A fire will burn one animal or 10 animals. The fire doesn't start because there are 10 or it's one. But competition will begin because there are more. Okay? So that's the difference. So in summary, density-dependent factors become more impactful as the population density increases. So with the density-dependent factors, you are talking of things like competition, disease, the food abundance, okay? Because these ones, the occurrence of this relies more on the presence of a higher population. But for the density-independent factors, these ones affect the population regardless of how many individuals there are. A drought will come, irrespective kama kuna miti ama hakuna miti. Okay? A natural disaster will occur, irrespective. But their competition For disease, for the abundance of food to occur, it is a factor of what? Density. So density-dependent factors are influenced by population size, while density-independent factors are not. Okay? So density-dependent factors, population size influences them. Density-independent factors are not influenced by population size. Okay. I will stop there for now. Then when we meet physically, we'll begin looking at now the life history strategies. Okay, so listen through that recording. If you have questions, note them down. Then when we meet in class, we'll begin with those questions before we proceed from the life history strategies onwards. But in case you have a question before and you feel like you just want to ask me before we meet physically, my email inapatikana chini ya hii. Okay, you can see chini ya every bit of every page. Okay, there is an email address, so you can email me your concern if it surely cannot wait. Okay, if it surely cannot wait, then you can email me, then I'll possibly get back, so that when we meet, we'll just now begin looking at the life history strategies. Okay, so I think that should be it, and I look forward to seeing you in our face-to-face engagement or reading your emails if you have a question that cannot wait. Thank you very much. Have a good weekend and see you next week. Thank you.